Hello, this video is entitled Binomial Distribution from section 4.2 in the Larson book. Now, the binomial distribution is a discrete probability distribution that satisfies the following criteria. So it's a special type of that case. There are several other special cases, but we're not studying probability distributions at length in this class, but there are several others like geometric, multinomial, Poisson. But we're going to only study the binomial, which makes sense because it's the most commonly used. So let's look at the conditions of this experiment. Binomial consists of n identical trials. N is however many times. So if you flip a coin 20 times or roll a single die 12 times, that would be your n. Now, here's where it gets a little different. Each trial results in two possible outcomes called success or failure. For example, if we're rolling a single die and we're rolling, let's say, we deem whatever we want to be a success. Of course, actually, though, the problem will tell us what we're saying is a success. But anyway, let's say you know 2 is your lucky number and you want that to be a success. If it's not a 2, we don't care what it is. In other words, we're either saying 2 or not 2. So you have a 1 out of 6 chance it's going to be a 2, then you have a 5 out of 6 chance it'll be something other than a 2. So only 2 outcomes. We don't care about anything else, just these 2. So that kind of trims it down a little bit here. Now, the probability of success on any one given trial is denoted by lowercase p. Capital P is the variable we use for probability, just like the probability of a certain number of successes. And Q is the letter they use for probability of failure, and Q, because it's the complement of P, is just 1 minus P. So that's what the Q just represents, the complements of each other, success and failure. The trials are independent and have nothing to do with each other. So let's say, for example, a single die is rolled 30 times, identify N, P, and Q, and we're saying a 3 or 4 is considered a success. So we're allowing 2 things to be a success. That's fine. There's nothing wrong with that. So either we get a 3 or 4, or we don't get a 3 or 4. Nothing else matters. So your N is 30 for the number of times you're doing this. Now, don't let this 30 affect your decision on what P and Q are. Now, all this is going to work together when we're doing the binomial probabilities, but for now, the lowercase p is always the probability of success on one trial, no matter how many trials you're doing. So you got 2 successes here, a 3 or a 4, so you got a 2 out of 6 chance of a success. And your failure then would be 1 minus 2 over 6. 4 over 6 reduces to 2/3. So as reduced fractions, they are 1/3 and 2/3. It doesn't matter whether we did this 30 times, 300 times, or 3,000 times. That would be the P and Q right there. Now here are some binomial experiments, flipping coins, rolling dice, and sometimes the problem will say, even if you're not sure, it'll say, just assume the conditions of a binomial experiment are met. So sometimes we do take liberties with things a little bit, but now drawing cards, I'm mentioning here, drawing cards can only be considered binomial if you replace the card. Meaning, because if you didn't, your next event would be, the probability would be affected by the event before. Other things would not be, like rolling dice or flipping coins, or let's say we'll talk about this in a little bit, if you were guessing questions on a multiple choice and assuming test, and you're assuming that one question does not depend upon the other. So that would be binomial. Okay, here's the formula, which you're not going to need. Both Excel and the calculator have a formula to do this. So I won't worry too much about going into that formula. You see I have it right here. I have it over to the right. Just leave that there. If you're interested, that's fine. If you're not, that's fine too. So Let's look at the calculator. Looks like I did Excel first on this example, so no problem. Got to open up a spreadsheet here. Unlike the probability distribution, the general probability distributions from the last section, which didn't really have a convenient Excel command, we had to sort of program it ourselves. There is a built-in binomial function in the Excel, so that's good to know. So we're saying n is 2, n is 10, I'm sorry, x is 2. Oh, okay, let me talk about, the x is the number. So that's what we're trying to do on these binomial probabilities. I left that part out here. But I didn't want to leave this statement out right here. Is we're trying to figure out what's the probability we get a certain number of successes in those n trials. Okay, so I left that part out. I'm glad I caught it. So, and there's the formula for that. And NP and X are the key variables. Of course, like I said, Q is in there, but remember, Q is always just 1 minus P. It's not a separate number you have to come up with or have to know. As long as you know P, you got Q. N is 10, 2 is for X, P is 1/3. So this means you got a probability of 1/3 of being successful on any one trial. And if you do this 10 times, then what's the probability of getting exactly 2 successes out of those 10? Now, I wrote out the Q here. Q is 1 minus 1/3, which is 2/3. Which the Q is important if you're using the binomial formula, which I have here in purple. However, in either Excel or the calculator, you don't have to tell it Q, you just have to tell it P, because it will just do the 1 minus P internally in the formula. So you don't have to tell it that, so you only have to enter the X, N, and P. So I'm going to do it for this one. Now the input on these is a little bit different than the calculator, the order of them. Binom, dist. Okay, the number of successes goes first, whereas the number of successes goes second in the calculator. I don't know why. I would think M would go first here, but I would have programmed it that way, but that's not me. So 2 goes first, N was 10, 1/3. Now, this is either going to be true or false. If you're just true means cumulative, it would mean less than or equal to. And I'll talk more about that coming up. So 2, for if I put true here, it's going to add up 2 plus 1 plus 0 successes and add all 3 of those up. So I want false right now, because I'm only calculating, anytime I'm only calculating one value, I want false. Okay, let me do the formula text command here. Since now we're kind of back to using formulas that we really weren't in the last section. Okay. But the false means you're calculating a single X value. In the var, in the calculator. You go second, and you hit this vars button right here, because right above that vars in blue is the DISTR you see right there. So you hit second, vars, but it brings up the DISTR. We scroll down. Okay. Now, similar to Excel, they have a function here that does it for one value of X, and then they have it for doing less than or equal to that X. See, where Excel, they just separate it by doing true for, in other words, A here would be false. There's no true false in the calculator. It's just whether you pick binom PDF or you pick binom CDF. CDF would be the same thing as if I would have used true in that calculator. In fact, I'm going to go show you something in that other thing here in a second. Okay. But anyway, this is a PDF. It's asking for the input. It wants n, and it wants p second here. Then we have 2. Paste it, then it's going to show the command if you'd entered it in kind of the old way where you just put the numbers in the parentheses. Here, it lets you enter them into a fancy little screen and then dumps them into the formula. All right, I think we got a match here, didn't we? All right, let's see what we got here. Okay. That looks like a match. Now what I'm going to show you is I'm going to copy this. Well, it shouldn't change anything. I don't think it'll change any because there's no cell references there. Yeah, but I'm going to change the formula. I only want to change one number here. So this is so there. The line 2 there is if you would have said what's the probability of 1 success, and then line 3 is what's the probability you get no successes in those trials, that they're all failures. Okay, you'll see the reason why I'm doing this here in a second. Now I'm going to add these up, right? And where's my sum? There we go. Okay, let's keep an eye on boldface this. Then I'm going to come down here and I'm going to show you. Actually, I can copy this, be quicker. Copy both of these. I'm going to change this to true. You see what happened? That's what I was trying to explain. The difference between the two is the true adds up 2 and 1 and 0 automatically. So you see I did them individually here with false and then added the individual results, so it's the same thing. Now let me show you over here the calculator. If I go second vars, I'm not going to do the 0, the all 2, 2, 1, 0, all that for this one. I'm just going to show you the CDF. Okay, 10 trials. P is 1/3. And it's 2. So you see this binom CDF command was the same thing as the Excel putting the true in there. That the true is equivalent to the CDF. Now I'm not going to go back and do this, but obviously if I would have done the calculator, I could, you could do that and check yourself if you want to. You don't need to, but I could have done this binom PDF. I did it for 2. I could have done it for 1. I could have done it for 0. It would have produced these exact same 2 numbers right here, which then would have added up to be this, which equals the CDF. All right. So they kind of, there's 2 similar functions in there. Well, like I said, Excel just uses one function. It just uses the true or false to separate the cumulative. All right, for any binomial distribution, the sum, and that's true for any discrete distribution, the sum of all probabilities would add up to 1. So I'm just mentioning that idea, as we might be using that here a little bit, but it's the same thing from the basic idea of discrete distributions, the sum of all your probabilities, because the number of successes you can have is anywhere from 0 to however many trials in you have. So let me use a smaller number, so I don't have to say too many numbers here, but let's say you have 5 trials. The number of successes can be anywhere from 0, 1, 2, 3, 4, or 5. And all of those probabilities would add up to exactly 1. So let's look at this single die example here. And I may not retype all these in the calculator, because like I said, as always, we'll see real-time examples in Excel. I mean, in my stat lab of Excel and the calculator in my stat lab, but it'll be here for you to look at. So 20 times, that'll be your n. This time we're only considering a 5 to be a success. So that's a 1/6 probability. And of course, I wrote we don't need the Q for the technology, but it's there for the formula. I mean, you never know. You may have a question that asks you to identify what Q is as a test question like this. Identify N, P, and Q. So just make sure you know that, well, you can use your notes, but make sure you know that Q is 1 minus P. We don't need it for the technology. So here, I did binom PDF, 20, 16, comma 3. And got this 23.8. And you see over Excel here, I did binom dist, but the 3 goes first. It's just the order they want them. And then the 20, then the 16, and the false. But you can look at these as reference, and you can compare. That way, when you go to enter it, you'll see what's happening. And I'm sure you'll get used to it quick enough. And, I forgot to put the answer there. I guess some of these, but I wouldn't have just left it as a wrong answer. In other words, that means I must have looked and saw that the answer was right. That's why I didn't just, well, let me slap this in there and hope that it's right. No, it would have been right, or I would not have, or I would have changed it immediately. I already forgot what the numbers were. I know 1/6, 3 out of 20, 20 successes. 3 is 3 out of 20. Okay. Yep. 3 successes, 20 trials, probability 1/6, and I want false this time because I'm only doing one calculation. And I guess so when these notes are published, you'll now see, that's not what I wanted. Yeah, so we'll see that this is what it's going to look like. So, dang it. So I'll copy this in here. But when you see the notes, you won't see that. What's there now? All right, so where'd I? Because I could have just copied the number once I got it, but. Okay, where do I want to put this thing? I think what I'll do is I'll move this over. All right, I paused the video for a second because I didn't need to waste your time by just having you watching me cut and paste, move stuff around. Let's see. Well, this I'm not going to pause for this because it doesn't take long. Anyway, let's see what we got here. Got a multiple choice exam, 25 questions, and we're going to guess on every question. So the idea is, let's say you're not even reading. In other words, we're not looking at it as well. I can eliminate 2 of these answers, pure guessing. So it's almost like someone could, if they were handing you a Scantron form, you don't even need to see the questions because the idea we're talking about is pure guess. You could just take a Scantron and just bubble it without even seeing the test, and that's essentially what we're doing here. Now, we have 25 questions, that's our N. Now, it says there's 4 choices for each question, so how do we turn that into a probability? Well, you think about it like this. There's 4 choices per question. The P, the lowercase p, is always the probability of success on one trial. So if you have 4 questions, you would have a 1 out of 4 chance of guessing any one question correctly. So there's where the 1/4 comes from. Now, if it phrased it in terms of like true false, it doesn't need to tell you how many choices, because true false is always 2 choices. But multiple choice has to tell you, because this could easily have been 5 choices for each question. So yeah, that there's no assumption with multiple choice like there is with true false that it's one or the other. You know, true false. That's it. We're going to guess, and of course I wrote the cue there. The probability of guessing 20 correctly. There it is in the Binomial PDF, scientific notation that times 10 to the negative 8. That means you start right there where that 1 is, the decimal, and you move it back 8 places. That leaves 7 zeros right in front of it. And that is an extremely low probability. You're kind of working your way into almost lottery land right there as far as guessing. Yeah, it's astronomically low that you could guess all 20 of those correctly. Now we're going to start getting into looking at the idea of answering our questions where it's not just a single value, where we have to use the cumulative, or we can use this thing, a binomial table. This is, when I show you this might be something you might want to use instead of the technology. Because if it's less than or equal to, it's easy because it'll be the cumulative. But if it's like greater than or equal to, it gets a little tricky. So this binomial table is going to be in D2L. It'll be in some folder there. Probably, charts in Excel, or whatever, because there's some Excel files we're going to be using in the 3rd unit, pre-programmed Excel files that I came up with. So now it's impossible to have a binomial table for every possible value of n and p, and this table only goes up to 20. So what I do on a test is just so you have this option. It may not be true on a homework, but on a test it can be, because I can keep the parameters of it, within that fit this table. I can make it be numbers that fit on here. Now, because you're still going to have to know how to do single probabilities, just either using Excel or the calculator. This doesn't solve everything, but it's going to solve anything on a test that involves adding probabilities together. I will make sure it's something you can find off this chart. But then again, you could still choose not to use this chart. Okay, now this we got to kind of be careful when we're reading wording, and this will come up later in another chapter too, in the 3rd unit. But I don't try to get too tricky, but we're not going to really need the differs right now. We will later. But at least means greater than or equal to. Fewer than, less than, that just means less than. No more than, at most, is less than or equal to, if it doesn't just say less than or equal to. More than, above, greater than are all the same thing. So it's not my goal here to kind of trick you, but we do have to be able to, read these things and turn it into the proper symbol to be able to get the proper probabilities. Now this little snippet is from the entire table. It's just so you see what it does. It has the ends here, and I think my table goes all the way through 20. N is 2, N is 3, all the way down to 20. And like I was saying earlier, your x's, whatever your n is, your x's are going to be all the way from 0 to whatever that n is. So 2, your x can be 0, 1, or 2. For 3, it can be 0, 1, 2, 3. So forth, so on. And then across the top row are different values for p. That's why it's impossible to make a table for every scenario. Let me give you an example. The rolling a die, the probability is 1 over 6, and if you make that a decimal, that's 0.166666 technically forever or whatever. I guess you could approximate it, I guess, and come up with a table value of 1.667 or whatever and stop it and put a 7 in there, but anyway, the point being is just too many other decimals you could have. But so we'll make sure that they work off of this for any problems where we're going to be adding stuff together. Now I'm going back to the guessing the multiple choice. Now, so suppose we have 20 questions with p equals 1/4 again. Find the probability of guessing no more than 4 correctly. And I said using the binomial tables, but I'll also show you the technology for this one because it is less than or equal to. That works good for the technology. But I'm going to show you all 3. So you have to be able to interpret that no more than 4 means less than or equal to 4. That's not the same thing as less than 4, because no more than 4 means we include the 4. So that gives me x values of 0, 1, 2, 3, 4. So if you're using this with just the regular, I didn't do this, but we're not using this formula anyway, but the idea is if we were, like I used to, you would have to do this 5 separate times and add them together, which, you know, can be done, but it's kind of tedious. So in other words, the same thing if you were using Binom PDF in the calculator, you would need to add 5 of them together. If you were using Binom DIST with false as the command, false, you would have to do that 5 times and add those together. But let me show you on the table. So you'd go down, I'll bring the table up for a second, but I got it. Go down here, 20 is the last one I have for the ends. And 1/4 converts to a probability, unlike the 1/6, like I was telling you for the die, 1/4 converts to 0.25, which is right off the table. Now you see when you look at this table though, on each page, the values are at the top of the page, but that's, you know, you can use a straight edge or anything, and you know, you can look down, but when I snipped it in the notes, I made it look like the probabilities were right above 20, but they're right up here. So it's this column right here. It's that column. It won't let me highlight that. No, it won't let me select it. Well, let me draw it. Okay, okay, so it's that column right there. And then we want 0, 1, 2, 3, 4. So it's all the way from there to here, right off the table, and then you would just add those numbers up. So I have it kind of cleaner looking right here. You see, so I got a box around all those 5 numbers. You would add those up, and you get 0.4148. So that's not bad. I'm not going to retype this one in there, even though it doesn't have the answer next to it, but the command it's correct. I'm using Binom dist. I'm using 4, 20, 1/4, but I'm using the true. The true means it will add up less than or equal to 4. Now the calculator, I showed you 2 things. Now I showed you the CDF, 20, I could have done the same thing with Excel, I guess. But anyway, I might go back, let's see. All right, I paused the video for a second to make a nice little edit for us here. I think I saw something I could make better, so I think I did. Now I got the Excel in there. Now let me show you then that the Excel, so for the true, it adds all of them up. But I want to show you and compare this to the table and also the calculator, same thing. Now false, so true means less than or equal to 4. False means just equal to 4. So check out this number right here, the 0.189 blah, 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 blah. That's the number right here at the very bottom, because that's a number for exactly 4 right there. But see, the true adds up 43210, boom, adds them all up. Same thing in the calculator. CDF doesn't use true and false, but CDF adds them all 4 up and gets this number right here. And then I must have hit enter twice here, whatever. That's okay. That's not 2 separate things, obviously, but PDF just gave me that x equals 4 number, the 1897 right there. So hopefully that's becoming a little more clear. All right. So let's see what we got here. Now you have to try to use the technology for this. You have to be pretty clever. I'll show you what I did down here. You know, you can do it, but yeah, I would strongly consider the chart on this one. And I'll explain what I did here. But if you're a little confused by that, that's okay. That's why I'm suggesting maybe the table's better for this one. So n equals 16. Probability of success on any one trial is 0.6. So we want to know n equals 16. Find the probability of more than 10 successes. All right. So the key is more than 10 means the same thing as greater than or equal to 11. So you would add up the bottom 6. Add those numbers up in the calculator and get your answer, and there you are. Looks like I didn't do the calculator, but I'll show it to you in the calculator, and at least if I do that, I'll paste it here also at the same time. And this is just what I was telling you about. For the problems that you have to add them up on, I'll make sure that they're on the tables. But anything else can be just a single value, can be any kind of probability. In fact, I don't want it to. For those, I don't want it to be one you can get off the table. I want it to be one that you use either Excel or the TI to get it. But for this, I want it to be something you can get off the table in case you don't like what I'm about to show you here. Now, this goes to the idea of that all the probabilities have to add up to 1. So all these probabilities have to add up to 1, which you don't have to verify that. Oh, by the way, these probabilities where they say zeros, that doesn't mean it's the exact number 0. It just means you don't start seeing any numbers till after the 4th decimal place at least. So I just wanted to mention that. But obviously, if you're adding those up in a calculator, you can ignore them because they're zeros. All right, here we go. So I got the little box around 11 through 16. Okay. Which means the part that's not in the box is 0 through 10. So we're going to use the idea of complements here on this. That means all that has to add up to 1. So that means the bottom part in the red box has to add up to 1, plus this other part has to add up to 1. Well, the other part is from 10 to 0. It's cumulative. It's cumulative probability. Oh, I did do it. Okay, I did do it in the calculator. I'm sorry. I did both the calculator and Excel. I just didn't show the answer in Excel, but I'm confident that it's right. So if you want to go knowing that they have to add up to 1 because they're complements of each other, 1 minus the CDF at 10 will leave you, by default, will leave you these right here, these 6 in the box. You see it gives you the 3288 right there. And then same thing here, 1 minus binom, but you have to use true, and you're still using the 10, the 16, and the 0.6. So I don't know how you feel about that. That's going to be up to you to feel any way you want about it. So I just because I said I just think maybe the table might be a little easier, but if you're determined to make it work like that, okay, that's up to you. Well, you know what? I'm going to change this. To make it more modern day here for my class, Excel. Let's look at this one real quick. Okay, blah, 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 blah. Fewer than 4. So that's the key wording here, fewer than 4. That's just less than 4, so it's 3, 2, 1, 0. It's a 3 of those. So that means you can get it from the chart right here. There's 6. There's 0, 1, 2, 3. You can add those 4 up, or you can just do a cumulative at 3. This time, it's don't do 1 minus here. 1 minus is whenever we wanted the greater than part. But for this, just do a straight up cumulative at 3. And you'll get the 9624, or binom CDF, because that's the cumulative at 3, and you'll get 9624. So, yeah. So the key is, the commands are nice there if you understand what to put in there. That's the key. For those cumulative ones, you have to be careful. Like I said, the last one we did was a 1 minus. Now, unlike the last section, this has a real nice formula for mean, variance, and standard deviation, and quick and easy. There's no built-in program in Excel or the calculator, but there doesn't need to be for this because it's no trouble. The mean is just n times p, and the standard variance is npq. Reminder once again, the q is 1 minus p. And standard deviation is always the square root of the variance. I know I sound like, keep saying that over and over, but that's because it's true. Like last section, we had a variance formula. Its standard deviation was the square root of that formula. Here's a new one, NPQ. Well, look at that. Standard deviation is the square root of NPQ. It's magical. (20-question multiple choice exam, 4 choices each. What is the mean number of successes? Expected number of successes. So this is where you have to realize that the probability is 1/4, like we talked about earlier. Because there's 4 choices. So read that carefully. It could be 5 choices, could be 3 choices. Doubt if it'd ever be more than 5, but so it's 20 times 1/4 equals 5. Now I'll explain to you what that means, although it's not going to ask you that on a test, or well, the variance and standard deviation I'm not really going to explain that much, but the mean means on average, like say basically kind of like the law of large numbers, but if you did this over and over and over, how many would you expect to guess right on average? Obviously, if you did this, you'll get one answer. Next time you get another answer. Every time, if you kept filling them out over and over, like Scantron forms at random, you get different results. So this mean tells you the expected number average of successes long term, which, you're not supposed to miss them all. You're supposed to get some of them right by guessing, but 5 out of 20 is not a very good test score, though, if it was of an exam, would it? So you're not supposed to miss them all, but it's not going to be very helpful to guess. Another way to think about this is if you have 4 choices for each question, and so you got a 1 in 4 of getting 1 correct, that means in theory, not in practice, but in theory, you should get every 4th question right. Well, if there's 20 questions, that's 5 blocks of 4. So you're thinking getting 1 right in each block of 4, and that would be 5 total. So you don't have to worry about thinking about that. I just wanted to mention to you what that meant. So this variance, just calculate it. 20 times 1/4 times Q, which is 1 minus 1/4, 3.75. Standard deviation, just square root of that. Here's another one. Same thing. Nothing too tricky there. I won't even worry about explaining that one, especially since it gives you the probability. Okay, here, let's look at this real quick. Not difficult. We just have to make sure we realize that the P is 1/6. So we're letting a 1 dot, a 1 facing up, be a success. So we roll it 30 times. 30 times 1/6 is 5. That means then 30 times we're expecting on average we would get a 1 5 times. But once again, that doesn't mean if you pull out a die, now and roll out 30 of them, doesn't mean you'll get 5 ones, but the average in the long term should be 5. So 30 times 1/6 times Q, which is 5/6, 4.167. Standard deviation would be the square root of That was 2.041. I've got a couple more. I may not do all of these, but this one I like. It's kind of interesting. You have to read this one carefully. Probability we produce a defective item. So maybe we got some business, we're producing something, we got 0.05. That seems kind of high. Quality control might need to look into this, depends on what we're making here, but I'd like to have a lot lower chance of, buying an item in a store. Suppose I want to go buy a new tool, new power tool, and I'd like to have, lower chance of it being defective than 1 out of 20. But anyway, we take 15, so somebody's coming in and looking at our business, maybe corporate's coming in here. If more than 2 items are defective, the process will be shut down for maintenance. So we want to find the probability that the process will not be shut down. So the best way to do this is to look at it as the not being shut down. So if more than 2 means shut down, that means 3 or more. 3 all the way to 15. So not be shut down would be 2 or less. So the opposite of 3 or more would be 2 or less. So if they come in and they find only 2, 1, or 0 defective, we're in good shape. We passed the test. And here it just says assume the conditions are binomial or met. It says you may use the binomial tables. You can use them anytime you want, obviously, but now let's see. So it's less than, once you establish less than or equal to 2, then we're in good shape. We can skip everything on this page. Just come down here. Now I use the table. 15, you got to find 0.05. I'm not saying 0.05 is in the first column, but I just cut it. Yeah, just for illustration purposes. Let's see. I think I can erase this. Okay, well actually yes, 0.05 is in the first column, but I could have just selected only that column. So you can get it from right here. You can just add up those 3 numbers for 2, 1, and 0 and get it that way. Just for the heck of it, I did 3 separate binom PDFs without getting their individual results and just added them together. That worked. But if we realize how to use the CDF, because it's less than or equal to 2, I used the CDF at 2 and got that answer. Same answer as this. And you see those 3 added together from the table. That's the same answer. Well, it's a little bit off, but not enough to cause. That's because of the rounding on this table right here. That's why it's slightly off. Because there would really be more if I had, but I needed to get everything to fit on a page. So if I would have shown more decimal places on here and would have added, then it would have been, but it's still correct. And here's the binom dist. If you use true, that's the same as your CDF here. So 2, 15, 0.05 true. So the probability, I just rounded to 964. So in terms of percentages, we have a 96.4% chance that we will not be shut down. So that's pretty good. And here's the mean, variance, standard deviation. That's easy enough. I don't know. I'll leave these 2 in here. Okay, I got the calculator and I got the Excel there for this one. And yeah, this one's not as good in Excel because you can't really use, well, you can't really use the cumulative in either one of them. I'll just mention this real quick. I don't think I'd ask this on a test, but between 2 and 4. See, so between 2 and 4 is not the same thing as just less than or equal to 4. It's 2 plus 3 plus 4. So it would take 3 binom PDFs added together, or 3 binom dist with the false here. Remember, false is the same as binom PDF there. Add those 3, or specifically pick, I label, there's the 0.65. So obviously this is not the first column here. I just didn't want to spread the whole thing out and take up room. So that's showing you it's the 0.65 column. And add 2, 3, and 4 that way off that table, which that might be the best way to do it for this one. And all right, so I'm going to, what they call, leave the exercise to the reader here or whatever on this one. So it's a good example as reference or whatever, but just to save time, I'll go ahead and move on. Okay, it's homework time for this section on the binomial distribution. So let's Let's do it. I'm going to start with this number 3. And students taking a multiple choice exam where each question has 4 choices. Assuming she has no knowledge of the correct answers, she decides a strategy in which she will place 4 balls, A, B, C, D, marked into a box, selects a ball, and then replaces the ball. So this is nothing more than if you're just randomly putting A, B, C, or D in there. This time it's just saying doing it, we'll draw balls to pick the letter or whatever. But that has no effect on the probability whatsoever. And so there's 6 questions. So if you've got 4 choices, that means you got a 1 out of 4 chance of guessing each one correctly. Now this thing will change up. I've seen it be as few as 2 choices. I've seen it be 5 choices. You know, it has A and B. I've seen it up to E, but this one's only 4. So yours might be different when you do it. And I'm not sure if the 6 stays the same or not. I don't know. But so we have N is 6 and P is 0.25. So the probability she gets 6 questions correct, basically 6 for 6. The calculator. Second distribution. It'll be binom PDF because we're only calculating one number here, not adding up a bunch of numbers. Trials is 6. P is 0.25. I could put 1 over 4 in there. X value means the number of successes we're trying to measure is 6. Paste. Enter. Now that's just scientific notation with we would just move the decimal over 4 places. It would leave 3 zeros in front. Calculator does that whenever the number's really small. Let me put this in Excel and show you. It's kind of adding on to where I was from the last section doing the probability distributions. So yeah, we'll just put these commands right down here, and I can actually I'll just copy the formula text thing and just move it down here somewhere. That way you'll see the formula. And I'll do it right next to it. Equals binom dist. The number of successes, it does a little bit different order than the calculator. Now, they happen to both be 6 here. That's just coincidence. But yeah, we'll do one where they're not the same. Probabilities 0.25. What's wrong with me? And then this one is you got to choose true or false. False means you're only calculating one number. True is like cumulative, meaning you're adding less than or equal to. So that's what binom CDF does in the calculator. So that is the same thing. I'll stretch it out a little. See, it shows more decimals. So it's got 3 zeros in front of it, and then 2, 4, 4, 1, 4, same as this. So let's see what it wants as far as the number of decimals. Maybe 4. 4. So with 4 decimals in, it'll be just 0.0002. All right then. Get at least 5 questions correct. Okay. 3 different ways you can do this. Now in the calculator, at least 5 then would mean 5 or 6. So add it together. So I can keep this one since we've already done 6. I can go plus and then do it for 5 and add it together, and that'll get it. And then just change this X value to 5. And that should be the 2 added together. Let's look at the calculator. Excel, excuse me. And then I'll just copy this. And I'll change the successes. That goes first. Successes goes first in this thing. You'll see it when it comes down there. Oh, dang it. I didn't mean to change that one. I meant to change. Well, I'm still adding those two together, but I still want to keep it the same order I had it. It won't. And then I'll make this one 5. So it's these two added together. So if you wanted to do a drag these together down and do a sum command. So there it is. You see the same answer, 0, 0, 4, 6. All right, so let's go with that. Now the other way is using the binomial table, which I mentioned on a test. I would, if you have to add probabilities up for any kind of question like this one, I would make sure it was fit on the table, because not every scenario is going to fit on that table. This one happens to, and I don't know if you'll get numbers on here where it won't, but on a test it will. So if I go up and then if I go use this, I'm looking for n equals 6, which is over, here we go. Well, let me count 0.25. You got to make sure that's in the 5th column. So when I scroll down, we'll see it. 5th column. It's that number I highlighted right there because that's 5 successes, and then the one below it. So it's 0044 plus 0002, and that will give you the 0046. So you can get it by adding those two numbers. I'm not trying to sell you on one way or the other, but I do like to make that table an option for that question on the exam. But and that comes in handy if you have to add several of them together. That one wasn't too bad. It was only 2. No questions correct. All right, let me. I'll just do a new binom. Well, it should keep some of the stuff in there. Yeah, all we have to do is change the x value here to 0. All right, so this, I'll come over here and let me just delete that row. I don't think. And I can go back. Oh, I forgot to copy this command down earlier. Sorry. Now you can see it. All right, there we go. Now you can see the difference on that last one. Well, instead of typing over, I'll just drag this down. And then now make that a 0 for the number of successes. That looks good, 17797, which will then round to 1780. Fantastic. Okay, no more than 2 questions correct. Okay, no more than 2. That means less than or equal to 2, because no more than, less than 2 would not include 2, but no more than 2 means 2, 1, or 0. So you can do 2, 1, and 0 and add them up, or you can use the cumulative, because that's what cumulative means, less than or equal to. Greater than or equal to is a little bit different story. Any kind of greater than, you can't use this. You can finagle it, if you can outsmart it. Like I did an example, I believe, in the notes where I was able to show 1 minus. But anyway, this one's not too bad because you would choose binom CDF here, not PDF. CDF means less than or equal to. So 6 trials, P is 0.25. So because I'm using CDF, when I put 2 in here, it's doing the probability of 2 and 1 and 0 and adding them. If this was PDF, it would only be just 2 by itself. Of course, I could use the chart for this one too. And I'll do the chart before I do Excel. So the chart on here, 6 in the 5th column. See, earlier we added the bottom 2. You would add the top 3. I wish I could highlight those. Can I highlight? Will it let me? Oh, let me. Good. Okay, there we go. That's 0, 1. Oh, wrong. Ah, forget that. I'm off a column. It's the 5th column. It's these 3 added together. 0, 1, and 2. That'll get it. And then now let's look at Excel. So the difference for Excel here is I'll copy this down. I have to pick, so it's not, the calculator has 2 different commands, PDF and CDF. This only has 1 command, but the difference here is whether you use true or false. Now I got to change that to 2 at the beginning, of course. 2, and then true is what makes it the CDF. Right? And you see, so there's the true, 8306. I think it's what the calculator had. 8306. I didn't add those 3 numbers in the chart, but I'm pretty confident they would have been 8306. Once I circled the correct column, I'm glad I caught that, because that could have confused somebody later if they'd have added those up and they wouldn't have matched. Fantastic. So how about the next one? Light bulb failure, 12%. So your probability of success on any one trial is 0.12. So keep in mind, I mentioned this in the lecture, but when we talk about probability of success, that doesn't mean something is good or bad. It means whatever you're trying to measure in the problem. We are trying to measure defectives. So that way, that's considered a success. So N is 10. So none are defective. So on the calculator, that will be second. Now we're back to Binom PDF. Trials, there's 10 trials, selecting 10 bulbs. P is 0.12. The X value is 0. $2,785. I'll come back and just change one of these. So 0 goes first for 0 successes. 10 trials. And then the probability was 0.12. And that one already has false in it. That's what I want. Looks pretty good there, 2,785. I like it. Get off there and let me switch. Yep. 2,785. Wonderful. Exactly 1. I can just do a second enter on this. Change 0 to 1. And then real easily on here, I can put a 1 right there. Same cell. 3798 rounded. All right, look at us go. 2 or fewer. That'd be 2, 1, and 0. Because of the answers from A and B, you could actually do the probability of just 2 itself and then add those other two numbers together. But 2 or fewer is the same thing as the one on the last problem that said no more than 2. That means 2 or less means it will include the 2. So I can do the CDF if you're comfortable using that. But you could do another PDF for 2 and then add that number you get from that plus the previous 2. Same thing. So if you wanted to try that just to see how that works. So 10, I need to change this to 2. Oh, I got it. I sit there and I had that on my brain. I taught myself out of to using the CDF. I was sitting there thinking about doing it the way I was just saying it. All right. 10.12. 2. Let's come over here. I'll use that CDF one down there that we already have set up for CDF. Okay, it's already got a 2 there, but our N is 10. And then our probability is 0.12. How about that? 8913? I like it. 8913. Now there's kind of a trick on this one. Here's because 3 or more, and this one would not be on the chart. Like I said, anything where this like this, I would make sure it was on the chart. But we can outsmart this problem. If you don't want to try to outsmart it, that's fine too. You could do the probabilities, individual probabilities, whether it's PDF on the calculator or false on the actually there is a way we could add them up, but I'm going to show it, okay, a little quicker than I thought it was going to be. So let's okay, let me do this first. I'm going to do it's 3 or more is basically the opposite of 2 or less. 2 or less covers 2, 1, 0, and 3 or more covers 3, 4, 5, 6, 7, 8, 9, 10. Now, you can add up those 3 answers and go 1 minus the sum of those. I'm sorry, not the first 3. 1 minus 2 or fewer, the 8, 9, 1, 3. 1 minus that will give you the right answer. Because that's already 2 or fewer. But if you would have done calculator, let's say it didn't have the 2 or fewer answer there, we could have entered it and done it this way. 1 minus CDF. There's 10. Yeah, okay, we already have those. Those are still in there because we just did that one. Like that. 1087. In Excel. Wrong file. I can get rid of that file. I don't need it anymore. Here was the true right there. So all I got to do is put a 1 minus in front of that, and that does it. 1087. But let me show you. Yeah, this would definitely be better in Excel for what I'm about to do than, because the calculator is no way to do it without literally adding them up one by one. But here, because we can use cell references and stuff, let's come over here, and I'll just come down here somewhere. I'll put we're going 3 through 10, so I'm going to put 3, and then I'm going to do equals A10 plus 1. And I'm going to drag that down until I get to 10. Okay, sorry. We delete that row, or edit, clear the cell, whatever. Either way. No formulas we're using it, so I wasn't worried about it. So I'm going to spread this out a little bit so we can get the formula in there. I'll get the numbers on it. So I'm just going to do any of these Binomial PDFs are fine. Okay, it's going to give me. Oh, I copied. Well, I want to copy it. Should copy the formula text command at the same time. Well, what I'm going to do here, which may be hard to see when I'm typing in there, but thanks to the formula text, we're going to see it beautifully. I'm going to reference the cell here. So you see my first, all we're changing on each one of these is the number of successes, the X value. So you see the first one here is an A10. So I'm going to come over here, the formula. I keep forgetting the formula's over here. I'm going to put A10. This should work. Okay, that's doing that value for you, A10. So now, let me copy all these down there, 3 through 10. And then this, as I copy these, it should change, because I didn't lock the cells in. It's got scientific notation there. Don't worry about that. Yeah, so you see it's doing it for each cell. A10 through A17, 3 through 10. Now, I can just do these as a sum right here. And there it is, 1087. So that's a way, because I was thinking that would be kind of a pain to type all of those in there until the cell reference idea hit me there. And I'm going, well, that's not so bad then to do it that way, to add up a bunch of cells. You can just reference them. All right, every once in a while I have a clever idea. All right, let's do one more and that'll be enough of this. Online retail orders, probability 0.04. 25 retail orders are placed. Assume it's binomial random variable. What are the mean and standard deviation? And you can verify this in the notes. This is not a command in either Excel or the calculator, so I'm just going to use the calculator. It's not like it's something special in Excel. The formula is just is n times p. It's in the notes. Really easy. So we won't even need for these two parts. We won't even need Excel, like I've said before, unless that's what you're using as a calculator. Let's go with 1. Beautiful. Now, the standard deviation is and this is, like I say, this is the formula that's in the notes. I'm not expecting you to know this off the top of your head. It's the square root of NPQ, where Q is 1 minus P. So I'm just going to put it in there as 1 minus P. 25 times, well, if I hit times instead of plus, that would help. Oh, good grief. What's the matter with me? 25 times 0.04, and then just go times, and don't even worry about, so just let the calculator do 1 minus 0.04. You don't even have to worry about it. Like that. And the variance would just be without the square root if it asks for the variance. Remember, standard deviation is always a square root of the variance. 3 decimal places, 9797. I'm going to go with 980 as 3 decimal places. Beautiful. And I guess it'll ask him some probability parts here. Let's see. Now we can use both calculator and Excel. Okay, just a couple of Binomial PDFs here. Trials is 25. And X value is 0. 3604. And let's make sure Excel. I just come back up here, over here, and pick any of these. I want to use one of the false ones right here, so that one's good. It was 0 successes. 25 trials. And it was 0.04. And false. So let's look at that cell compared to the calculator. Looks good, doesn't it? 3604. Beautiful. Okay, wants to do 1 now. So I'll just change that 0 to 1. Come over here to Excel. I'm gonna, in case it makes us, we have to add something up. I'm gonna go ahead and copy this one to the next cell. I don't want to lose that number just yet. And then here I'll change it to 1 and you'll see it. 3754, I like it. Beautiful. All right, this is very similar to the last one. 2 or more is the opposite of 1 or less, and the first 2 added together would be 1 or less. I didn't type that in there last time, but I'll do it. Or, yeah, I'll just show you this, and then, so it really would be minus the sum of those 2 answers. But we can do it that other way where it adds them all up, like we came up with. So I'll put a plus here. So it should be 2642. Got it there? I can go 1, let's say we hadn't done that first part. I can go 1 minus binom CDF at 1. Sometimes people don't like using that CDF. They're worried they're going to make a mistake. So I'm trying to give you different options here. Oh, okay, that would help. I was thinking Excel mode where the trial goes first. I mean, with successes goes first. 25 goes first here. So that means that's cumulative. It's adding 1 and 0 together. This is basically doing exactly what I did above, just by actually manually entering in the numbers. There you go. Same thing. So Excel, I could do let's see if I still have that other 1 minus sitting over there somewhere. Yeah, I do. So I can change that to a 1. Successes to 25. Probability to 0.04. There it is, 2642. And then, if you like this way over here we came up with earlier, I'm going to delete this row though. I'm going to change that to a 1. Nope, I'm sorry, change that to a 2. Because it said more than 1. Or it should have said 2 or more, one of the 2. 2 or more. Which is the same thing as more than 1. But I got to go to, oh, this goes all the way to 25. Oh, wow, okay. Now, without this method, it would really be a pain, but we're gonna be good now. I don't want to go that far. Yeah. So I got to copy the other things down. Uh, and oh, okay. I got to change the formula right here first of all. I mean, the P is not the P is and N. I didn't change N and P. N is 25. P is 0.04. I still want to reference cell A10. That's correct. So now I'm going to grab the corners, grab it and corner it all the way from, Now let's drag this one all the way down to the end. And then all the way I can grab them now and sum it up. There it is. 2642. We got it. We are that talented. And I believe that's it. That's going to conclude this section 5.2 on the binomial distribution.